Before we get into some more complicated examples today, I'd like you to think about the following questions. The first question is, what was the relationship between a function's graph and its inverse graph? Think about what we saw yesterday when we graphed the function and the inverse, and why did that relationship exist? The other question is, what are the pros and cons of each algebraic method that we learned? We did these on the back side of the sheet yesterday. They were called the undo and the switch and solve method. Why would you use one versus the other? If you need to refer to your classwork from yesterday, take that out. I'd like you to pause the video and think about the questions that I just asked. Hopefully you remember from yesterday that the relationship between a function's graph and its inverse graph was that they were the exact same shape and size. They had just been reflected over the line y equals x. And the reason that relationship existed is because a regular function maps x onto y, and an inverse undoes it. It maps y onto x. So all coordinate pairs end up switching, which is the same result as when you reflect a point over the line y equals x. The other question I asked you to think about are the pros and cons of each method. So a lot of people like the undo method because it's very quick and very simple. And some other people like the switch and solve method because it has a very direct step-by-step way of solving it. For most functions that we look at, you'll have a choice of which method that you're going to use, but there are going to be a couple of exceptions where you will have to use the switch and solve method to find the inverse of the function. Yesterday, I asked you to find the inverses of these functions. So please take out your work from yesterday and check it over. We'll go over the first function, the f of x equals 4x plus 12 first. You can use either method. I'll be explaining using the undo method, but if you use the switch and solve method, you should get the same result. The first thing we need to do when finding an inverse is use the proper notation. So we show the inverse of f of x by using that little -1. The next thing we do is start with an x. You can leave a little bit of space in case you need to put something out in front of the x. So if we were to undo this function, you almost want to think about it like if you were to solve for x, what would you get rid of first? And in this case, since we have this extra term, this plus 12, the plus 12 is the first thing we would want to get rid of. So we want to get rid of plus 12 by subtracting 12. The next thing we'll need to get rid of is this 4 right here. There's two ways of getting rid of the 4. One is to divide your entire function by 4. The other would be to multiply your entire function by 1/4. You'll see both methods, so you want to get used to looking at them both ways. Recognize that they're the same. The next function we'll look at is this h of x equals the square root of x plus 2 function. And we'll start off using the correct function notation. Start with an x, leaving a little bit of space. The first thing that we need to get rid of in this function is this root, since it's over the entire expression. So the way we get rid of the root is by doing the square of the x. The opposite of square rooting is squaring. Then we need to get rid of this plus 2, so to get rid of that plus 2, we just put a -2 at the end. And that is it for question B. The expression should just be x squared minus 2. For the last example, same thing, start off with the correct notation, start off with an x. The first thing we need to get rid of in this function is the 4, because the entire expression is being divided by 4. The opposite operation of dividing by 4 would be multiplying by 4, so we're going to start by multiplying our x by 4. The next thing we need to get rid of is this exponent here, since the whole expression is being raised to that exponent. The opposite of squaring is taking the square root, so in order to get rid of that, we need to take the square root of the entire expression. And then lastly, we need to get rid of this -1. The way to get rid of the -1 is by adding 1. So this should be your final expression here for the inverse of h of x in question C. Please check over your work and fix any mistakes that you might have. The one new thing we're going to add into inverses today is a more complicated example. In this example, we cannot use the undo method for two reasons. One is we have an x in the denominator, and the other is that we have two x's. So we can't undo what's done to two x's at the same time. So anytime we have an x in the denominator, or you have multiple x's, you need to use the switch and solve method. So we're going to start by changing our f of x to a y, just to make it a little bit easier to not have to rewrite the whole thing. And then the first step is switch and solve is switching your variables. So the y is going to become an x, and the x is going to become a y. The next step is to solve for y. It's a little bit more challenging in this example because there's two y's in the equation. So we're going to start by getting rid of the fraction to make the equation a little bit simpler. One way to get rid of a fraction is to cross multiply. So if we put that x over 1, we can do 1 times y to get y. And then we have to multiply those two expressions together. While that didn't help us get rid of the second y, we at least don't have fractions to deal with. So the next thing we're going to do is figure out how do we change two y's into one y. This y right here is kind of stuck inside the parentheses. So what we're going to do to get rid of that is to distribute. Now the y is out of the parentheses, but we still have two y's. The way we're going to change two y's into one y is by getting every term involving a y to one side and every term not involving a y to the other side. So this has a y, does not have a y. So if we designate the left side of our equation for terms involving y and our right side of the equation for terms not involving y, we just need to move this term to the other side. The way we're going to do that is by subtracting xy from each side. Now since these are not like terms, we can't combine them, we have to write them separately. So we write y minus xy is equal to, what's going to be left on the right side would just be negative x. Getting all the y's to one side and everything not involving a y to the other side helps you solve for y. The reason that is both of these terms involve y now. They have a common factor of y. So we can now factor out a y. If I factor a y out of y, I'll be left with 1, because y divided by y is 1. If I factor a y out of this term, I'll be left with that negative x. We've now succeeded in having only one y in the equation, so to get that y by itself, we need to do the inverse operation. Y is being multiplied by 1 minus x, so we need to divide by 1 minus x. And to maintain equality, we do the same thing on both sides. So we have succeeded in getting y by itself. The last step is to use the correct notation to show that it's the inverse of f of x. And that will be your final result. One thing to note, if you put the y's to the other side of the equation, you'll get the same expression except for all of the signs will be opposite. That's okay because the expressions will be equivalent. On the answer key, I listed both forms of the expression so you can check your work on your practice today. If you need to watch this video again to understand how to do this type of problem, please do that. If you haven't already copied the example down in your notes, please rewatch this portion and have this example in your notes so it can help you on these types of problems on your practice today. The last thing I wanted to tell you about your practice today is a key for putting things in correctly in your graphing calculator. The first section of your practice problems asks you to graph two functions as well as the line y equals x in your graphing calculator. If you have a complex fraction like this, you need to make sure that if either the numerator or the denominator has multiple terms, you enter that into your calculator using parentheses. So for example, in this function, the numerator has two terms, so when you enter it in, we need to do parentheses 4 plus the cube root of 4x, close the parentheses, divided by 2. If the denominator included multiple terms, you'd have to do that for the denominator as well. Also, for those of you that have TI-83s or 84s, the way you find the cube root on your calculator is by hitting the math button. When you hit the math button, the screen will show up and you should see the cube root as an option. For most of the calculators, it'll be the fourth option, so you can scroll down to the number 4 and hit enter, or you can just type the number 4 on your keypad. Today you're going to be working with the person sitting next to you on these inverses. You can work together, check your answers on the answer key provided on the Google Calendar, and any questions you might have, I will set aside some class time on Tuesday for questions.